Assalamualaikum dan salam sejahtera. So this is our project that's titled Smart Parcel Sorting for Pfi2 Residential College Hub. So the main objective for the Smart Parcel Sorting for Pfi2 Resident College Hub is to develop a system that have automated the process of sorting each parcel based on the state using machine vision. Machine vision is an example of machine learning application as it encompasses all industrial and non-industrial applications in which a combination of hardware and software provide operational direction to a device in the execution of their duties based on the acquisition and processing of image. Machine vision system can be applied with the Internet of Things to help students to monitor their parcel. So the problem segment is online shopping are becoming more common and are currently on a rise in popularity due to the recent pandemic COVID-19. A Unimap PF2 Parcel Hub is using a manual method to sort the student parcel and key in detail data of the student parcels. The manual method is really taken too much time when parcel arrive or delivered at Unimap PFI Hub. The student can claim their parcel on the next day because of manual method they use. Students at PF2 Resident College have many blocks. They need to sort the parcel by block to make it easy to students claim the parcel. So the objectives for the smart parcel sorting for PF2 Resident College Hub is developed based on the objectives stated below. To develop an IoT-based monitoring and controlling system for sorting parcel. The second, to identify the label on the parcel using the image processing method. And the last is to develop the sorting mechanism based on parcel label.
When the parcel is put onto the conveyor belt, the parcel will move under a camera that is used to identify the alphabet on the box. The parcel will stop for a while under a camera to identify if it's block A, B, or C. Once the letter is identified, the conveyor resumes moving until it reaches its predetermined compartment for its block, where it will then be pushed into its compartment. Once the camera detects the alphabet, it will also keep track of the number of the parcel, such as the current capacity, range of time for the compartment to be filled, lot name for each container range, the logging error, and so on. Using OpenPySL and logging library, it will then create a .log file for logging and a .slss file for a datasheet. Pfi2 is used to create a GUI so that the user can interact with basic functions such as opening a window for the camera view, turning on and off the conveyor, opening ThinkSpeak, removing or applying filter to the view, and changing the API key.
This is the flowchart of our conveyor system for smart parcel sorting for Unimap Pfi2 Residential College Hub. In this system, we assuming only referring to 3 blocks in the residential college. There are 3 types of parcels with alphabet A, B and C. The A, B, and C is referring to Block A, Block B, and Block C of the Residential College of Unimap Pfi2. After the OCR detect, it will determine in which bucket the parcel will enter. For example, if the OCR detects alphabet A, the conveyor will turn on, and separator flap A opens for 3 seconds, and the parcel will be separated into bucket A. Next, if the OCR detects alphabet B, the conveyor will turn on, and separator flap B will opens for 6 seconds, and the parcel will be separated into bucket B. Lastly, if the OCR detects alphabet C, the conveyor will turn on, for 9 seconds and the parcel will be going to the last bucket.
Circuit diagram. So here is our circuit diagram. Our main controller is not MCU V3. This controller I use to control the whole system using C programming. The controller has Wi-Fi module, not MCU, which has the ability to send and receive data to ThinkSpeak. This is to communicate with camera machine vision. We are using two servo motor for the separator flap to separate the balls. This is motor driver L298. The function is to control this motor right here. This motor right here I use to control the conveyor. We are using DC motor 3.6 volt. The whole system is powered by two battery with 3.7 volt and with current 1100 milliamp hour. So here is our whole system hardware. The conveyor system are mainly built from plywood and 3D printed items. This box right here I use to put the circuit. We are using this camera to detect the alphabet on the box on the conveyor, and then the laptop will process the data and decide which box are A, B, or C using Python programming. The data will be displayed on the laptop.